Welcome students, this is the 26th lecture on digital land surveying and mapping. In this class I will discuss about the other errors that we come across during use of total station. The class will be discussed under following heads like introduction. Now other errors that we come across in the total station other than the instrument error are the distance error, peripheral error, natural error, because we walk in nature. So there will be some factors or disturbance factors which causes errors in total station measurement due to nature and personal error. So I will be discussing these points with an intention that we should take care of, so that these errors should not be occurring in our measurement, or we should take due care so that the errors are minimized. Now the main errors which come across in total station is due to non-permanent adjustment of the instrument, and we have seen that most of the errors arises out of the non-permanent of the instrument can be taken care of by taking the observation in both face left and face right condition, then taking the average, or we should go for calibration, through which we will get the calibration parameters which will be automatically taken care of by the software to take or to make necessary corrections. Now there are different types of errors that we come across which leads to the error in measurement of distance. The one of the most prominent error is the zero error. Now what is zero error? Actually this instrument is having many centers like electrical center, physical center or mechanical center, and when we make use of the reflectors, then we have the optical centers. So all these centers may not be in a position where we expect it to be. So there is some error in this position, and those errors are called zero error. Now this zero error is defined or determined by using a test called 3-peg test, which is very simple. In 3-peg test what happens, we do make use of 3 pegs, peg 1, peg 2, peg 3, and if we can measure the distance between peg 1 and 2, peg 1 and 3, and distance 1 2, 1 3, 2 3. All these distances we can measure, and there are two errors. One, so we can find out the errors E1, E2, E3, and the error in 1 2 and 2 3, that means E1 and E3 should be equal to E2. So the error in measuring distance from 1 to 2 should be equal, error in measurement between distance 1 and 3 should be equal to error in measurement 1 and 3. So from that we can compute the amount of error that is associated with the zero error, and the amount of this error actually is constant. Now another error which is, this is also very important, that is called, if we remember, the total station makes, especially phase shift method, makes use of the wavelength of the frequency multiplied by the number of, and del phi 360 like that. So if we remember, this is the, that means the fundamental frequency, wavelength of the fundamental frequency is the most important multiplying factor to the number of cycles, and then this. Now this wavelength means frequency of the signal. Actually in total station it itself generates the signal and generates, and this has having particular wavelength. Now, if there is any discrepancy in working of the signal generation part of the instrument, or there may be some other problem, then there may be some deviation in the frequency or wavelength. So, this will lead us to error in distance measurement, error in distance. So, this is called cycle error, and there may be some unwanted interference between the signal generated and processed inside the total station. Now, there is another error called cycle error. So, another error is called cycle error. Now, this error arises out of the interference between the signal generated and processed inside the total station. So, these two errors are associated with the frequency or the wavelength, and this is a very important thing to be taken care of, and that can be measured or identified by making use of the calibration called baseline calibration, and and manual will have some standard procedure for this baseline calibration. So, we should make use of that baseline calibration, and we should find out what is the amount of error, and we have to make necessary correction. Now, sometimes these error may exceed the limit, permissible limit in that case, or sometimes it may not be possible to do the necessary correction or calibration. In that case, we have to send our total station to the manufacturer. So, actually distance error are very critical in measurement process. Now, apart from this distance error, there are some other error that is associated with this instrument. For these errors are associated with the peripheral instrument that we use in this total station, like we have the tripod stand. Now, in this case we are making use of a very good quality of tripod stand whose head is perfectly made as well as leveled, means, and the fixings are nice. So, well maintained and good quality tripod stand, but many times with many instrument or whenever we will use this tripod stand in the field, some loose, it may get loose, or there may be some breaking up of the instrument, or this tripod stand or its head, or there may be some wear and tear. So, similarly there is a tryback. This tryback should be very good, that means well made and well maintained, as well as perfectly it should be leveled type thing. But in low cost, or if we make use of this more in the field, if we handle this roughly or due to different field condition, this may not be in good condition to use, but in spite of that if we use, then there is a possibility of errors associated with this. Then we make use of optical plummet. We know we make use of optical plummet here for centering purpose, but if the optical plummet is not in good condition, then the centering that will be done through this optical plummet may not be correct. So, all these will lead to different errors in our leveling as well as errors while we will be taking the measurement. So, these errors are termed as peripheral errors. So, these errors can only be avoided if we make use of proper type of peripherals, like our tripod instrument should be of good quality, its all these legs should be properly fixed with its head, the head should be properly level, tieback should be of good quality, as well as it should be properly made like that, and all these instrument has to be maintained properly or in good condition for future work. So, in this way we can minimize the peripheral error. Only way to minimize or to remove by using proper instruments and proper maintenance of these parts. Apart from this instrumentation part, there is another type of error called natural error, because we go for field observation in the field. So, we have to expose our instrument to the sun, to the wind, then our instrument has to be set up on the earth, as well as the observation we make use of some electromagnetic wave or light, so it will pass through the atmosphere. So, all these actually contributes to some problem sometimes, like if we go to some place where it may be, or some days in a observation there may be a large wind. Due to wind, this instrument may vibrate if it is not properly set up, or the wind is very high, then it will obviously vibrate. If it vibrates, then its centering will get lost, and if its centering gets lost, all our observation will get lost. Also, if we take the reflector base measurement, then the reflector will also get vibration and our all measurements will be incorrect or associated errors. So, in those cases, first we have to see that neither our instrument nor our reflector should get vibrated due to wind, and that will be possible only if the wind is of mild in nature. But if the wind is very violent, then we should stop working, and under no circumstances we can allow our observation on a vibrated instrument or vibrated reflector. Then temperature is a very important parameter which has to be taken into account, because if the temperature fluctuates heavily, then it adversely affect the body, specifically the body of the instrument, and if it affects the body of the instrument, then it will definitely affect the working of the whole system. And as we know that total station is an electronic instrument, and electronic instrument malfunctions if it goes beyond the ambient temperature, or there is a very fluctuating in temperature. So, in this case also we should take care that our instrument should be maintained within the ambient temperature as the manufacturer has given in their manual. And in some cases, if we are unable to maintain the temperature, or the nature is fluctuating so much that the temperature is uncontrollable, then in that case we have to stop our work and we should wait for a favorable time to work. Then the refraction. So, as you know that our total station measurement makes use of the electromagnetic waves, and electromagnetic wave will get refracted when it will passes through the atmosphere. Now, when the atmosphere is calm and quiet, then the amount of refraction will be within regulated manner, and that can get modeled, and we can make use of those model to make the necessary correction. But if the atmosphere is turbulent, then the refraction amount is also will be very much varying, and it cannot be modeled, and so the correction cannot be done properly. So, So, refraction actually bends, it will bend the ray of light, and rapid variation in the atmospheric condition makes the arbitrary bending and expansion of the going this side that side. And the one way to avoid or minimize the refraction is to make use of the instrument, to keeping the instrument as above the ground as possible, because the variation in atmospheric condition or the temperature of the atmosphere is more near the surface than above. This small variation above, so the refraction will be less critical if we maintain the instrument as high as possible. Now, in worst cases we have to suspend the work, we have to wait for the work for the favorable atmospheric condition. Another consideration is very important, is that whenever we will set up the tripod stand, we must see that the tripod stand is set on the surface of the earth, which is sufficiently strong. It should not be fluid state, or it should not get disturbed whenever we walk, or it should not get settled as we fix up the instrument. So, this is a very important thing, neither there should be unequal settlement of different legs. So, in this case also you can see we have because of the plane surface we have used this frame to set up our instrument, so that our instrument should be in proper fixed condition. So, properly fixing as well as standing of the instrument over the ground is very important, and particularly choose the ground which is moderately hard, and so where our tripod can be kept with sufficiently fixed, and we should avoid soft ground, we should avoid spelled roads, etc. So, with this I want to go for next type of errors. The another errors which is important is the personal error. I already told you that actually personal errors are the most severe. Gross errors are arises due to personal error. Now, personal error arises due to different reasons. Many times the surveyor may not have the proper knowledge, or they may be novice worker, they may be casual, and there may be so many reasons, personal reason. However, the personal errors due to those things, that we can say that our instrument should be set up at proper location. So, sometimes it may be difficult for a person to identify the proper location. So, in the field, because it is easy to satisfy the condition in office, but when we want to transfer the location to the field, many times it may not be possible. Now, sometimes there may be problem in centering the instrument. So, due to imperfect centering we will get different types of error. Now, suppose I want to set up the instrument somewhere here, but we have set up the instrument somewhere here. So, the object here A and B, between which we want to find out the angle, this is the angle we want to find out, but as we have set up the instrument in this location, we will get the like this. So, you can see that this is the error, this is the error, and this is the error. So, now in one case. So, in another case, if we set up the instrument, if we want to set up the instrument here, and we have set up the instrument there, we want to set up here, we want to. Now in this case, if the angle is something like this, we want to find out. This is the angle we have to find out, but actually but we have find out this. Now what I wanted to emphasize that the error that will be associated with the measurement with respect to centering will depend upon the mutual orientation between the actual and between the which we have set up, required setup and actual setup. So between the mutual location in whether it is in the along the same line or it is sometimes we may have the location like this. So in that case the location, though we want to get this, we are getting this. So mutual location of the exact position and the position where we have located, the amount of error depends, and this can be minimized. During observation we should go on checking whether our centering is maintained or not. If it is not maintained, then we should center again and then we should take the observation. Similarly, this is the error due to centering. Similarly, there may be error due to leveling. Now if the instrument is not properly leveled, the meaning is that the horizontal circle is not horizontal and the vertical circle will not be vertical. So we will be having our measurement of angle error. So before starting to measure any angle or after measuring the angle, we should check the level of the instrument, and before starting if we see that it is level, if it is not level then we have to level it. After measurement if we find that it is not level, that means there is some discrepancy in our measurement, so we have to discard that measurement. So we should find that the instrument is level before the measurement, we should check, we have to find it. After the measurement again we check, we have to find it is level, then only we will accept that measurement. So improper leveling, then improper use of clamping and tangent screw. So since this instrument has a number of screws, like this is the horizontal main screw, this is the vertical plate main screw, this is the tangent screw to the vertical plate, this is the tangent screw to the horizontal plate, there are collimation screw, there is a eyepiece screw, there is a focusing screw. So there are so many screws are there, so there is every possibility that we do make some mistake in making use of the screws. So this needs proper training and experience and also practice, then only we can avoid this thing. Many times we fail to focus our lenses. So because before, as I told you, during temporary adjustment, first we should focus the eyepiece lens so that we see the crosshairs in the reticles clearly. This is the eyepiece lens focusing. Then we should orient our telescope to the object, towards the object, and bisect the object, and to bisect nicely the object we should use the focusing screw to focus objective lens focusing screw to focus the object, means to make the image of the object fall in the plane of the reticle. So and that should be done clearly. If we do not do, then there is a mistakes in measurement. So and there may be some parallax sometimes, so we should see that there is no parallax. So these things we have to be very careful during our measurement, and sometimes over careful may also lead to some errors, or careless plumbing and placement of error. That means sometimes whenever we make use of the reflectors, we may be careless in holding it, it may not be fixed, it may not be straight, it may be properly level. Actually with this plumbing bob there is a level, so that level should be properly seen and maintained. So with this I like to conclude today's class on other errors in total station observation. So the summary is that apart from instrumental error due to lack in permanent adjustment of the total station, there are many other errors, and these errors are also very significant, and we should take care to see that those errors should not be occur during our total station measurements, and we should take care to eliminate or reduce as much as possible. With this I like to conclude this class, and next class I will be talking on propagation of error. Thank you.